So let's now look at relative refractive index and absolute refractive index. And we are now going to begin with a relative refractive index. So what is the relative refractive index? You can say relative refractive index is the ratio of sine of angle of incidence to the sine of angle of refraction for light traveling from one medium to another medium of different optical densities. Okay? So, relative refractive index, we basically look at moving from any media to another, provided the two medias have different refractive index. That is what you're calling relative with respect to, relative to, okay, from one media to another of different optical density. Or you can say is the ratio of speed of light in one medium to speed of light in another medium. Okay? We can also define it as the ratio of speed of light in one medium to the speed of light in another medium. So basically we can say it is n equaling to speed of light in medium 1 divided by speed of light in medium 2. It can also be written as that, and that is basically talking about what we are calling relative refractive index. We look from one medium to another, or the speed in one medium divided by the speed in another medium. So now if we say, suppose the incident ray is in medium 1 and the refracted ray is in medium 2 or the second medium, then what is very true, we said this can be the refractive index can be denoted by any 1 to 2, okay? Refractive index of 1 to 2 should be equivalent to sine of I in 1 over sine of R in 2. The sine of arm of incidence, the arm of incidence is in the first media, and the sine of and the arm of refraction is in the second one. So we are looking at, if we have something like this, where this is our medium 1, and this is medium 2, and this is our angle of incidence, angle of refraction. Okay, so we can now say the refractive index of 1 with respect to 2, of 1 to 2 is the same as sine of angle in medium, sine of angle of incidence medium 1 divided by the sine of angle of refraction in medium 2. That is how it can basically be denoted. So that is about relative refractive index. Now let's look at absolute. The absolute refractive index of a medium, in bracket, substance. How can we define that? We can define it as is the ratio of sine of angle of incidence the sine of angle of refraction, okay? Sine of angle of refraction for light traveling from vacuum to another media. So you can add there maybe of different from, you can, if you just stop there. Is that it? It is traveling from vacuum to another media. So when we are talking about absolute, we basically look at the first media should be vacuum. If the first media is specifically vacuum, we therefore say that that is absolute refractive index. Okay? So we can say, or it can also be is the ratio of speed of light in vacuum to speed of light in another medium. Okay? So if we are talking about absolute refractive index in terms of speed, it will be speed of light in vacuum to speed of light in what? To speed of light in the second medium. So that is to say, I can say n equaling to speed of light in vacuum divided by speed of light in medium, in the second medium. Okay? So basically you can say it is if we are to talk about that, we can say that is basically an idea of saying if this is my I, this is my R, and then if this is the air and this is medium 2. Okay? So we can say now from air to the second medium that I don't know can be equal to sine I over sine R. But because we know refractive index of air is 1, we just say refractive index of the medium is sine I over sine R. But the whole point here is that when we're talking about absolute, basically we look at the first media should be vacuum. But if we are talking with the relative, it can be any media to another media. Please get the difference. The difference is that if we are talking about relative, it should be from any media to another. But if it is absolute, strictly the first media should be vacuum. Like you can even see, if I give an example here of absolute refractive index of water. Okay? Look and maybe say absolute refractive index of water. I can ask you one of the material. So it would mean that it is the ratio of sine of angle of incidence to the sine of angle of refraction for light rays moving from vacuum to. Okay? So you can say is the ratio of sine of angle of incidence to the sine of angle of refraction for light traveling from vacuum to water. Okay? So that one is now called absolute refractive index of water. If it is absolute refractive index of glass, it will also still be the ratio of sine of angle of incidence to the sine of angle of refraction for light traveling from vacuum to glass. That will be refractive index of absolute refractive index of glass. If it is the paraffin, you also say from vacuum to paraffin. Okay? So that is basically the difference between absolute refractive index and the relative refractive index. Let's meet now in the next episode of our video.